before we get started on the second page of the stoichiometry review for the test, I am going to do a quick molar map for you. So remember, we have moles in the bubble in the middle. We can go from moles to grams or from grams to moles. Let me get this part of the map figured out real quick. So if we're going to go from moles to grams, we are going to multiply by the molar mass. So that's what you calculated on the first page when you use the periodic table to help you out. If we go from grams to moles, we are going to divide by the molar mass. I'm just going to write it as mm again. So remember, this is just the sum of all of the atomic weights of the atoms in your compound. If you want to go from moles of one substance to moles of another substance, we're going to use a mole ratio. And we're going to get into that a little bit more, but remember, the mole ratio has to have a balanced chemical reaction because you use those coefficients. So that's the number right in front of the letter, in the front, not in the subscript, but in the front, and that is going to tell you the mole ratio, the values for the mole ratio. I'll put this aside for a second. All right, so our first question asks us how many moles of F2, so that's fluorine, are needed to react with 56 grams of H2. So remember, H2 and F2 are both diatomic molecules, and our given here is 56 grams of H2. I'm going to set up my little fence starting out. So if we look back at this is going to be a two-step problem because we're going to need to go from grams of H2 to moles of F2. So to do that, we're going to have to go from grams, divide by the molar mass of hydrogen. Now we're at moles of hydrogen. We are going to use a mole ratio to get us to moles of fluorine. So that's two steps to get us to moles of fluorine. So remember, that first step was to divide by the mole ratio. Well, hydrogen is 1.01 grams per mole. So that 1.01 grams goes on the bottom because we're dividing, right? 1 mole is going to go on top. So 1 mole of H2 is equivalent to that gram of H2. Oh wait, this is a great learning experience for everybody. This is 1 gram of H, not H2. So in order to put that 2 there, we have to double this. So 2.02. Remember, it's diatomic. All right, so our second step is then going to be the mole ratio. We're going to use our balanced chemical equation here. Double checked its balance. There's 2 hydrogen on this side and this side, 2 fluorine on this side and this side, so we're good. So what we want is moles of fluorine. So in order for everything else to cross out, moles of fluorine is going to have to go on top. And we do want it on top in the answer. On the bottom, we want these moles of hydrogen to cancel out, so we're going to put it down here. To get these numbers, we have to look at our balanced chemical equation. In front of fluorine, there's 1. Remember that empty space counts as a 1. In front of hydrogen, there's also a 1. All right, when we plug and chug in our calculator, we get 56 divided by 2.02. And then we're going to multiply that by 1 over 1, which is 1. So we get 27.72 moles of fluorine. All right, next question. How many moles of magnesium bromide are needed to produce 422 grams of magnesium chloride? So we've got that 422 grams of magnesium chloride. Again, we're starting at grams. So we're going to divide by the molar mass of magnesium chloride so that we can get to moles of magnesium chloride. Then to get to moles of magnesium bromide, we're going to have to do a mole ratio. So let's get started. So magnesium chloride, we've got magnesium has a molar mass of 24.31. Then we have chloride, which is 35.45. We have 2 of them, 35.45 again, or you could multiply that in the calculator by 2. So we get the molar mass is 95.21 grams. And remember, that's always per that 1 mole of magnesium chloride. All right, one more step. We're going to do the mole ratio. So remember, we want to know the moles of magnesium bromide. So that's what's going to go on top. To cancel out this moles of magnesium chloride, it needs to go on the bottom. Don't forget the 2. All right, then we look at our balanced chemical equation. The coefficient for magnesium chloride is 1. Coefficient for magnesium bromide is 1. So this is me having double checked that this is correct. There's 1 magnesium, 2 chlorine, 2 bromine, and 2 sodium. So this is balanced. So it's a 1-to-1 ratio. So we're going to take 422. We are going to divide that by 95.21 and essentially multiplying it by 1 again. So we get 4.43 moles of magnesium bromide. All right, next question. How many moles of oxygen are needed to react with 12 grams of iron? So we take our 12 grams of iron. So remember, we're going to go from grams to moles of iron. So we're going to divide by the molar mass of iron, which is 55.85. There's only one of them, grams of iron per 1 mole of iron. So noticing that my molar mass is always per 1 mole. So this is not from your balanced chemical equation. This is always 1. Then we're going to multiply that by our mole ratio. So to do a mole ratio, we need that balanced chemical equation. So we're going from moles of iron to moles of oxygen. So moles of iron is going to go on the bottom because we want that to cancel out. Moles of oxygen is going to go on top because we want that in our answer. When we look at the balance coefficients, 3 is for moles of oxygen and 4 is for moles of iron. So we are going to do 12. We're going to divide by that molar mass, which was 55.85. And then we're going to multiply by the molar ratio. So we're going to multiply by 3 and divide by 4. And our answer is going to be 0.16 moles of O2, so moles of oxygen.